There's a secret that scientists have hidden from us for centuries. One that powers every modern machine you've ever touched. In a world where American technology evolves by the minute, this silent mechanism has remained unchanged for over 100 years. It doesn't look like progress. It looks like nothing. Yet without it, every aircraft, turbine, and high-speed engine would collapse into chaos. This is the hidden force that keeps the industrial world alive, a piece of engineering so small, it holds the weight of everything that moves. But do we really know where the foundations of these giant machines begin? How something so familiar, like the airplane above us, depends on it completely. Stay for a moment. The truth behind this invisible technology will surprise you in the next few minutes. Every movement in the modern world begins with one small component, the precision bearing. From the turbines of jet engines to the wheels of bullet trains, from robotic joints to medical scanners, nothing turns without it. Inside those massive machines, bearings no larger than a coin withstand thousands of kilograms of load, rotating millions of times without failing. In a high-speed train, one defective ball bearing can unleash catastrophic friction. In spacecraft, even micro-vibration can destroy control systems. Every gram of motion depends on absolute perfection. These bearings do not shout for attention, they whisper with precision. But how can something so perfect be born from raw, imperfect steel? To answer that, we must return to the beginning, where heat and pressure shape the first form of accuracy. It starts with chromium steel rods cut, heated, and pressed under 1,200 degrees Celsius. Hydraulic machines exert hundreds of tons of force, forming the glowing billets into precise circular rings. The sound is relentless, metal colliding with metal, sparks slicing through the dark. When cooled, each ring is trimmed and measured within 0.02 millimeters. At this stage, the bearing is only strength without refinement. Raw power waiting to be sculpted. The geometry exists, but precision still sleeps inside the steel. To awaken that precision, the metal must face fire again, not to destroy it, but to reorganize its atomic order. In a furnace glowing at 870 degrees Celsius, the steel enters transformation. Oxygen, time, and temperature define everything. Within seconds, carbon atoms realign, converting soft austenite into hard martensite. The structure of the metal changes permanently. It remembers the fire. Then, at 180 degrees Celsius, it is tempered to relieve internal stress, balancing hardness and flexibility. Too hot, and the ring fractures. Too cold, and it deforms under load. The result? Hardness between 60 and 64. HRC strong enough to survive 500 million rotations. Yet even perfect strength is useless if surfaces cannot move against each other. For that, the steel must become smoother than light itself.
Through discipline. Hardness 63.5 HRC. Invisible success.
Here begins the silent art of destruction. Diamond wheels spin at 40,000 revolutions per minute, shaving steel by a micron at a time. Coolant floods continuously to control temperature and vibration. Laser sensors scan curvature, maintaining tolerances within 0.0001 millimeters. The air vibrates with a metallic hum, steady and cold. Each pass removes imperfections invisible to the eye until the surface becomes a perfect circle, its reflection uniform, without distortion. Engineers call this point mirror geometry, where steel finally learns to be still. But inside the bearing, the real challenge lies in the spheres, the moving hearts that must roll forever without friction. How are they made flawless? Thousands of steel balls tumble inside rotating drums lined with diamond powder. Over 48 hours, they grind each other down, erasing every microscopic defect. Gradually, their surface roughness drops to raw 0.002 micrometers, 50 times smoother than optical glass. Each sphere gleams like liquid metal, reflecting light with perfect symmetry. Laser interferometers measure them one by one, any ball deviating by even 0.0001 millimeters is discarded instantly. This is where motion meets perfection, geometry so pure that friction can no longer exist. Yet perfection alone means nothing unless every piece aligns in harmony. The next step will bring all these silent components together.
Raw 0.0002 millimeters confirmed.
In the assembly hall, technicians work in clean, white rooms. Every bearing is built by hand under magnification. The inner ring, the outer ring, the cage, and each polished sphere are aligned with oil films, only microns thick. Gloves move carefully, no sound, no wasted motion. A single mistake can cause catastrophic imbalance at high speed. When the cage locks in place with a metallic click, the bearing becomes a microcosm of motion freedom within control. It is not just assembled, it is calibrated to survive. But before these bearings are allowed into engines or turbines, they must pass the most extreme test of all, the measurement of silence itself. In a soundproof chamber, the bearing spins for the first time. Sensors record vibration levels below 20 decibels, quieter than human breathing. The shaft accelerates to 12,000 revolutions per minute, yet the hum remains smooth, constant, pure. Engineers monitor data streams showing friction coefficients of 0.0015. The graphs remain flat,
chaos.
steady, without noise. Here, motion becomes invisible. Sound becomes information. Perfection is proven not by strength, but by silence. And when that silence holds, the bearing is ready to carry the world spinning endlessly, unseen. Every jet engine, every wind turbine, every factory robot relies on this invisible perfection. A bearing weighs only a few grams, yet it sustains the force of entire machines. It endures heat, speed, pressure, and time without ever being noticed. Inside every movement on Earth lies this silent companion of engineering.
Perfection.
In the pursuit of
proven by
perfection,
silence.
the goal was never noise or glory. It was the quiet mastery of precision. Nothing moves without it.
Every
This
machine
is the sound of
depends on
perfection.
invisible perfection. Silent companion of engineering.
Nothing moves without it. This is the sound of perfection.